Have you ever looked at something like x plus 3 equals 7 and thought, easy, but then you see x plus 3 greater than 7 and it suddenly feels a little weird? Well, if that's you, you are in exactly the right place. Today, we're going to completely demystify linear inequalities. And I promise by the end of this, you'll realize it all comes down to one simple, game-changing rule.
So here's our game plan. We'll start by nailing the huge difference between an equal sign and a greater than sign. Then we'll get into the language, cover the rules that you probably already know, and then we hit the big one, the crucial twist that changes everything. After that, we'll see how to actually draw our answers, and we'll wrap up with some pro tips to make you a master.
All right, let's dive right in. What is the real difference between an equation and an inequation? You know, it's more than just a different symbol. It's a totally different way of thinking about what the answer even is. Okay, look at the left. An equation is like a perfectly balanced scale. For x plus 3 equals 7, x absolutely has to be 4, period. No other number will work. But now look to the right at the inequality. This is an unbalanced scale. For x plus 3 to be greater than 7, x could be 5, it could be 6, it could be 10.5, heck, it could be 1,000,000. Any of those will work. So we're not hunting for a single point. We're describing an entire range of possibilities.
So, to talk about these ranges of answers, we're going to need a specific language. Let's get to know the 4 basic symbols that are really the foundation for this whole topic.
Here they are, our 4 key players, greater than and less than. Pretty straightforward, right? But check out the 2 on the bottom. You see that little line underneath the symbol? That line means or equal to, and it's a really big deal. It means the number right on the edge is included in the answer. So when we say x is greater than or equal to 4, it means x can be 4 itself or, of course, anything bigger. Now, I've got some really good news for you. If you already know how to solve a basic equation, you are about 90% of the way to solving an inequation. Seriously, most of the rules are exactly the same. Just like you've always done, you can add or subtract the same number on both sides, no problem at all. The scale stays tipped the same way. You can also multiply or divide by any positive number, and again, nothing changes. So far, so easy, right? But notice how I keep saying positive numbers. What do you think happens when a negative number gets involved?
And that question right there brings us to the one rule, the one big twist that changes everything. If you only remember one thing from this whole explainer, make it this. This is called the reversal law.
So I'll ask you directly, what happens when we take an inequality and multiply or divide both sides by a negative number? Does everything just stay the same?
No, it doesn't. In fact, everything flips.
And here's exactly why it has to flip. Let's start with a simple truth. We all know 5 is greater than 2. Easy. But watch what happens when we multiply both of those by -1. We get -5 and -2. We've jumped to the other side of the number line, and over there, -5 is further to the left, which means it's now less than -2. The entire relationship, the entire truth of the statement had to reverse.
So here it is, the reversal law. The single most important rule. Anytime you multiply or divide both sides of an inequation by a negative number, you must flip the inequality sign around. A pretty fun way to remember this is the alligator trick. You know how the alligator's mouth always opens to eat the bigger number? Well, when you multiply by a negative, the bigger number switches to the other side, so the poor alligator has to flip around to get its meal.
Okay, so our answer isn't a single number. It's this whole set of them. So how do we actually show that? We need a way to visualize this potentially infinite range of correct answers.
Now, there are a few formal ways to write your solution down. You might see set builder notation or interval notation, which basically just shows the start and end points. But honestly, the most visual, most intuitive way to really get what your solution means is to just draw it out on a number line. And when we draw it on the number line, we use a simple little code. An open circle, one that's not filled in, means the starting number is not included. We use this for greater than or less than. A closed filled-in circle means that number is included. That's for our greater than or equal to or less than or equal to. It seems like a tiny detail, but it makes all the difference in the world. All right, let's put this all together. Here's a step-by-step guide and a few final checks you can use to make sure you solve any linear inequation that comes your way, with total confidence. Think of this as your checklist. It's a reliable process that works every time. You simplify, you gather your terms, and you get the variable all by itself. You know, just like a normal equation.
But then you get to step 5. This is the moment of truth. You have to pause and you have to ask yourself, did I just multiply or divide by a negative number? If the answer is yes, you apply the reversal law and flip that sign. Then, and only then, do you write down your final answer.
And here's one last really important detail that can completely change your final answer. You have to know what kind of numbers you're allowed to use. Look at this. In both cases, the question is x greater than 3. But in the first row, we're told x has to be a natural number, a positive whole number. So the solution is just the numbers 4, 5, 6, and so on. But in the second row, x can be any real number. That includes all the decimals and fractions. That's why the solution is a whole interval, covering every single number from 3 all the way up to infinity.
And finally, a few little pro tips to make life easier. If your answer ends up looking backwards, like 5 less than x, use the mirror trick. Just flip the whole thing around to x greater than 5. It means the exact same thing, but it's so much more natural for our brains to read. And the most important tip of all, always verify your answer. Just grab a number from your solution set, like if your answer is x greater than 5, pick 6, and plug it back into the original problem. If the statement is true, you know you've nailed it. It's a 2-second check that will save you from so many simple mistakes. So let's sum it all up. The big idea is this: solve an inequation just like you'd solve an equation, but be on high alert for one thing. If you multiply or divide by a negative number, you must reverse the sign. Always check what kinds of numbers are allowed in your answer, and always double-check your work by plugging a number back in. That's really the whole thing right there.
So there you have it. You now have the complete toolkit for tackling linear inequations. It's not some big mystery. It's just a system with one key rule you always have to remember. So my final question for you is this. Now that you know the one big twist, what's the most complex problem you feel like you could take on? Thanks for joining me.